Thank you very much for having us. We feel honored and proud to be given the opportunity to speak to you here this morning. As my name indicates, and I guess the accent as well, it is German, and I am German, but I've been given the honor to work for a couple of years, I guess, ahead of me here in South Africa, and I'm responsible for the two divisions at Siemens here in South Africa, responsible for Southern and Eastern Africa, which is the digital factory and the process industries and drives division. And I'm, again, Martin, glad to be here, and I hope I have something of use to tell to you. I did find a nice quote on the internet. It said, "Life in business is like underwear. It must change." And there's some truth to it. But I guess digitalization actually, in essence, does change everything. It changes the way we communicate, it changes the way we travel, it changes the way how we communicate. And I actually can speak of this as of my family up until just recently. It was in Germany, and we had a 10-hour flight distance, but it doesn't appear that far away when in the same time zone on Sunday afternoon you sit in front of your device and talk to each other just like this. And then think about 15 years back, it wasn't possible. You had to go somewhere and put in some coins to make a phone call. So that is really what changes and drives it to us personally right immediately. And so digitalization changes a lot. It can disrupt, and it is a chance for those that do embrace change, and it can be a risk for those that stay behind, as many times before. So just some examples to somewhat also demystify some of those things that sometimes are being discussed and we hear in forums but don't really know where to put it. But when we look in our own environment, individually and personally, we find, oh yeah, all of a sudden, yeah, you're right. I'm used to read my books on my Samsung or iPad just like this, where years ago, I had to go to a bookstore. Just recently, my daughter installed the Spotify thing on my device as well, and I was thinking, like, when the last time have I bought a CD? And I was walking in the airport, and I saw a store that still had CDs. I wonder how long that's going to last. But I'm just saying, all of a sudden, you see that change affecting you personally, as well as with the marketplaces or ride-sharing from a taxi that had to be called somewhere, and nowadays you just take your device and honestly, I have to sometimes say, I judge the speed of innovation in with the speed of the thumb of my daughter going over this device, putting stuff on it. So, that is all coming towards us. And just to look in what are the trends, the mega trends that we are in, maybe just to confirm, is it really taking place? Yes, I think all of us know demographic change is taking place. There are some people out in the world that still deny that climate change is happening. I think it is happening. And we are aware of that. And so in that context also we see, well, the digital transformation is coming. And when have you last hooked up a Bluetooth device, maybe like this little sound boxes at home, to your devices? Or you thought you were hooking it up to your one device that you had with you. And while you were doing that, it showed up like device A, B, C, D, C, and so forth, all those things. So it's coming. The amount of devices being connected are exponentially increasing, and a couple of years ago I didn't even know what a zettabyte is. Sometimes we wonder today of what that's all about, but it's massive. It's coming towards us. And I think sometimes it's in human nature to not believe that things are coming. But I think all of us in this room learned somewhere in school that water and steam were producing power to move things. And Werner von Siemens himself was part of that portion when the Industrial Revolution took place, where electrification was a major part. And me personally, I went to school and went out and was automating machines, production cells, production lines, and all of a sudden production facilities and complete factories. So that happened. And at the time we were thinking, like, and I heard that this morning, oh, how about you better apply your muscle other than having that little robot doing there? It's there. And so is digitalization. We are really going towards that. It's out there. And so the fourth industrial revolution is there and is taking place. But digitalization must not come for the sake of itself. It must lead towards something that benefits, ultimately benefits us, not the manufacturers themselves. It's got to benefit us. And when we talk about speed, then it's coming down to, I go somewhere on the internet and want to buy and I saw was it your or some other brand's sneakers out there. I want to buy those sneakers, and since Saturday, we do have that soccer game, I would like to have them by then. I would like to have them by then. So speed is something that I expect to be just normal. So the manufacturers have to adopt to that. Same with flexibility. Before I came here, I ordered a car. I skipped the brand. And I chose, the interior, the exterior, the package that makes it a bit more sporty looking, and the color as well. And just shortly before that thing went into production, I was thinking like, ooh, that color looks a little granddaddish. So I want to change it. And I changed it. And that was my expectation also, that almost to the final moment, I have the ability to change something in order to meet my personal wishes, demands, whatever. So the manufacturer has to put that in place to respond to that. Quality, whenever I buy, and we talked a lot about phones today. And again, when I came here, I had got that new phone of mine. I looked at it, not a scratch. And if there would have been a scratch or any ditch, I probably would send it back. So manufacturers are really being driven by, ultimately, even if it's mass production or mass customization, it has to be to the final limit of quality. Because nothing less is expected from all of us. Because every ditch is not good looking. We need that. And so is efficiency, do more with the same invest, or even do more with less invest. And as technologies are coming as well, we realize that manufacturers are really changing or can use technology to drive the development and the evolvement and the production of what they do and what they produce with those new technologies. Like, for example, generative designs, applying principles from nature to come to a design of something. Or a system of systems where applying systems in a sum of something results into more than just the sum of those individual systems. Or additive manufacturing while we're doing this. A couple of years ago, we didn't even know what that was. Nowadays, when you look of what can all be accomplished with additive manufacturing, it's just out there. As well as changing the way on how products evolve. We're talking about service already, and we'll do a little bit later. But cloud systems, not just for the sake of connecting something to the cloud and put data out there, but for example, to utilize and leverage analysis services that are being provided to really drive the quality, the evolvement of a product actively forward. And if companies want to do so, they ultimately, in order to apply all this, must develop towards a digital enterprise, if I might say so. And they then, over the process of ideation, realization, and utilization, better apply those elements to the whole value chain, to the whole life cycle of when they start with the idea and the product design, where and how they plan on how the production is supposed to work, where they define how the production is ultimately engineered and how it's going to be executed, as well as the services. And in order to do that, we ultimately would be good, recommended, if we could apply a digital thread to it. Combine this all to what you said, Martin, in your opening page. Really look at it from an integrated point of view, from the start, from the idea towards the services in one holistic system, so-called. And if you do that, and that's what Siemens is offering in its so-called digital enterprise suite, we are based on a collaboration platform, and Johan, you have talked about this already. It's called Team Center, which is the backbone, respectively, the collaboration platform that interlinks and interconnects all this throughout the different levels of the value chain and life cycle, and ultimately feeds it all back, or has the ability to feed all back in those individual phases of that value chain while we applying the principles in each and every individual chain. And we heard this morning already also at least sometimes, the topic of IoT, the Internet of Things. And Siemens Digital Enterprise Suite does come with something that we call our cloud-based open IoT operating system, MindSphere, and we will demystify some of that a little later, that then ultimately connects all these systems and brings it into this ever-increasing cycle that ultimately then brings this whole process into a perfect virtual twin, a virtual copy, which we then call the digital twin. And I think to make that more visible, we put something together today to guide you a bit through those individual phases of what we just said, on how to design a product, on how to design your production, and how to execute on your production, as well to apply services. And this is what I want to go through with you in the next couple of minutes. And we do that based on a product that we build on our own. So we do build in one of our factories in Germany, we do build this so-called field PG. This is what service technicians or engineers use when they go on site and extend the application, do services, and it's a product of ours, and let's apply those principles. Going to the value chain in product design, our portfolio scope or portfolio Annex CAD, software CAE, Cobos, and I'm glad to have a bit of a backup here, Cobos, in the room as well that knows a lot about that stuff. It's the environment where we can virtually, but actively, build, conceptualize, design a product. And this is what we do here. And once we have done this, we come to a phase where we say, what if we have built this product virtually, before we then actively, physically build it, could test it, and we simulate it. And like, for example, here being shown, a notebook or a PC does have a processor that produces seed. And in this environment, we could apply certain rules that show us how is the heat developing, and how and what would we need to test or to further design and develop and change in how to address heat participation, for example. And we could also then again go back from the testing environment into the designing phase and readjust. Go in there, readjust, apply new rules, and look, for example, if we could apply an additional cooling bracket, or if we would add another ventilation area to the design of this product, to ultimately come up to the point where we say, okay, now it works. That's how it's supposed to work. But we didn't build it. We have built this in that virtual environment. I'm known to many, CAD and CAE, but this is how we would do it. And then, when it comes from the mechanics to the electronics, I think it's an environment that we also offer to then say, well, now that the physics and the mechanics are being built, how about we test the electronics? And what's the behavior of those individual elements to each other, and how does it properly work? To then even say after that, we could also apply principles on where we develop, simulate, validate, and manage the software itself. So from the idea, building this in an environment that is software-based, that does lead us toward having a product with its behavior functionally built, ultimately, and all of a sudden leads us towards a digital twin of that product. And I know the initial discussions on how the digital twin, it's somewhere, up here. Let's demystify that. It's a piece of thing that we can design, conceptualize, build, test, and rebuild to the phase where we say it's perfect. It's what we want. And it does come with the behavior, how it's supposed to be. Next thing would be, how do we produce this thing? And based on our collaboration platform, based on the criteria that we have put in for this individual product, we can create a bill of processes, so to say, that can ultimately help us designing of what the proper production process to build this product would be. And this would lead into something where we say, well, we could simulate working conditions. I think she's called Jill. That's what our software says. It must not be Jill in general, but we can look at how are the tables supposed to be arranged, what pieces and parts are supposed to become when does she do when does she have to do what movement. And we can simulate that until we say, I think now it's fine. The ergonomics are fine, the feed of material is fine, and Jill could work with this properly. We could also for sure apply that to, well, I think we talk about this and we don't have to deny that automation is playing a vital role as well. And so we look how to apply then the robotics to the individual. And again, other than having Jill doing this manually, how can we automate and ultimately put this all together as individual elements for our overall production flow? And once that has been done, and once that we have a good idea, this production cell as we have here is working fine and is doing the right things, we could look at also, for example, then, how is our overall production site looks like? And look at what buffers do we need, what energy consumptions are resulting out of this overall setup, and what are shortages potentially. So we can simulate also what is happening if Jill and the robot are not being fed by material that is need to be there in order to do it in a proper flow. That can be done here, and all of a sudden we recognize ourselves after building this, testing this, that we come to a point that we say, well, now out of this we can also do what many of us know potentially, because we all know, not we all know, but many of us know, yeah, we need to automate that thing, and now we need to build code for my automation system. My PLC needs to do this. But we can generate that in that same environment and push it down into the PLC, actually here, a virtual PC, and test it out how it's all working. To then, after that, push it down in the real PLC. And I think that's a very powerful thing. We are not, and we recognize already, these things are interconnected and not separated, and that's why we start building this holistic thing of the product and the production, because they are interlinked, and we interlink them already before we even build anything on a virtual twin environment and can test it all out. And then we do the commissioning, and we really go into real life, put it out in the system, test the robot, and then really go down to the shop floor and test things out. So it's working. And if it's not, we go back again. So we got the digital twin of the production. It's demystifying a bit. And then we have, for sure, our production itself. We need to plan, we need to schedule. So we do have, supporting elements in that digital enterprise suite that help us doing our production ultimately. Plan for it, assign the resources, schedule the task. It's supportive. We can go and add work instructions, because Jill, here and there, she needs work instructions. So we put it in the same system. We put it out there in order to properly let the production flow and go from there. Same with quality. Quality as a driving element, as we said, because it must lead into quality. The product must be top-notch, is something that is supported by the so-called Digital Enterprise Suite. And then, and I think many of you might have heard about TIA, the principle that came out with the third industrial revolution, the integrated automation of things, is ultimately where it ends up, at the shop floor, where the devices are, where the PLC do what they are supposed to tell the machines to do. It's down there on the shop floor. And so we have built the whole value chain from the design, from the idea, from the design, to the production design, to the production execution. And then we come to a point where we say, well, what's important now? Or what would be a good mean to ultimately and continuously optimize that process? And that would be something in a holistic view that takes data that has been produced at the end and feeds it all the way back into the beginning or into individual elements. And so all of a sudden, we got this scenario here. We have built a digital twin of a holistic value chain, so to say, from product, from production to performance. And this ends up in this. This so-called Digital Enterprise Suite, which here now represents the shop floor. We have the departments that do the ideas and products and engineering. We do have the departments that steer the production itself, and we do have the people that put the automation in place and ultimately control it. And that's and Martin, you said it in your introduction, it's about product lifecycle management, that suite that helps us really doing the PLM, the MOM, the manufacturing operations management, that helps us executing our production, as well as our automation systems that ultimately do it on the shop floor, which then we consider our digital enterprise suite. And I think, Probus, have I just skipped on the IoT? I think I skipped more or less on the IoT. Let me go back one slide, if I'm not mistaken. Up there, the MindSphere, is then this thing when people also talk Internet of Things. What is it? It's ultimately nothing more that picks data from the shop floor and feeds it back, ultimately, into all those phases of the value chain to continuously and ultimately optimize our product, our production, and the services we can apply for the sake of you and I, because I would like to have the highest quality in the shortest time at the best value and price for me, and that's what it all drives. And that's how we want to support manufacturing companies with this. Yeah, and people do it, and they reduce their assembly times by a significant amount of hours. Others reduce their engineering times and they decrease their time to market and build nice cars with it. And there's us as well, as if we supply or apply the same principles. Because in one of our factories in Hamburg, we produce every second a high-quality product. That's the output of the factory. Every second at a quality level of 99.9989%, which is great. Which is actually awesome. Oops. That is digitalization too, I guess. Let's try it again. No, it's not working. Then let's skip it. It was a nice video. Thank you very much for that.